Happy Thursday. I think it's Thursday. Anyway, today we are proving angle relationships. So we've done points, we've done segments, and now we're talking about angles. So here it just states that given any angle, the measure can be put into a one-to-one correspondence with real numbers between 0 and 180. Basically what it's saying is you've got this straight line and you've got angles that are going to equal up to 180 on a protractor. So that's all it is saying. Next, this one here. So this is angle addition. It's no different than when you have a line segment. So here, if you have ABC, so you really have to watch these. So ABC, and again, if you had a highlighter and kind of outline this, ABC, so you can actually see it. And it's really saying that angle ABD plus DBC, so this whole thing is going to equal ABC. So let's just write that. This looks a mess. So let's do angle ABC is equal to these other two together. So ABD plus angle DBC. I think that's a better way to say that. There's no room here and it just doesn't make any sense. Okay, supplementary theorem. Obviously, you're going to know that it's going to equal 180. So the two angles equal 180. So I'm not going to add anything there. We're just going to move on. Complementary, same thing. Your two angles are going to equal 90. Reflexive. Reflexive, we know, it's like a mirrored image. So angle 1 would be angle 1. So it's going to be to itself. Same, that reflexive. So it's no different whether it's a segment or a point or whatever it is. With an angle, it is, if it's something equal to itself, it will always be the reflexive property. Symmetrical would be the same thing. So we have angle 1 is equal to congruent to angle 2. Therefore, angle 2 would be congruent to angle 1. So again, if I put a line of symmetry here, it would be the reverse. Where's this one? Did yours leave you too? Let me see if I can find this one. Transitive property, because we could do this. Well, I could do this. So if, let's just do this. If angle, can you see me? If angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, comma, then we can transfer that information saying that angle 1 is congruent to angle 3. Sometimes it's actually good to write it on our own. Whoop. Transitive. So at least these terms don't change. They just change whether it is a segment or an angle or whatever it is. Okay. Next. All right, so now we're talking about congruent again, supplements. So supplement means it's going to equal 180 degrees. Now this really kind of makes me think of the transitive. This is close to the transitive, but they're supplements. So it's got a little different theorem. So supplementary to the same angle, supplementing are congruent. Okay, so measure angle 1 plus angle 2 is equal to 180, and then angle 2 plus angle 3 equals 180. Therefore, angle 1 must be congruent to angle 3. It's kind of a weird twist. Okay. Same thing here. Complement meaning 90. So it seems transitive let's put seems. Seems. Transitive. But this refers to complements, which is 90 degrees. And of course, supplement is 180. A linear pair, linear meaning line, supplementary. So same thing here. So angle 4 plus angle 5 equals 90, and angle 5 and angle 6 equals 90. Therefore, 4 and 6 would be the same. Vertical. Again, you guys struggle with this so much, so I'm not for sure how I can make this any clearer. That when you have vertical angles, angle 1 and 3 are congruent. They're the same. And angle 2 and 4 will always be the same. Perpendicular, my favorite word, meaning right angles. So again, this is the sign. It says perpendicular lines intersect to form 4 right angles. So we all know that all of these are going to be right angles. All of these angles are going to be right, every single one, because these lines are perpendicular. Therefore, all of these angles will be congruent if you have 90-degree perpendicular lines. You also know the perpendicular lines form congruent adjacent angles. So 4 and 2 are the same. 2 and 1 are the same. 1 and 3 are the same. 3 and 4, they're sitting. They share this side. That means they're going to be congruent. Same thing here a little bit. So if 2 angles are congruent and supplementary, then each has to be a right angle, because there's no way to have a supplementary angle, which is 180, and they be congruent unless they are both 90. Here, if they are a linear pair, they have to, and they're equal to each other, they're congruent, they have to be right angles. All right, let's take that information and actually do some math. This is the part I love. Let's see where I am. Get your calculators out on this one. And make sure we're labeling. It says, find the measure of each numbered angle and name the theorems that justifies your work. So if measure of angle 2 is 115, how much is angle 1? Basically, since this is a straight line, right, 180 minus 115 equals 65 degrees. And that's a supplementary theorem. 2 angles. B. Angle 2 is 20. You can tell this is a 90-degree angle, so find 1. 90 subtract 20 equals 70. So measure of angle 1 must be 70 because of the complementary theorem. Complement theorem. Okay. Oh, intersecting lines, $10, it's vertical angles. Ah, I'm wrong. Interesting. So the measure of angle 7 is 5x plus 5. Measure of 8 is 10x minus 4. This is why it's so important to label. So we're talking about, and I'll do this often, we're talking about these 2 lines together, which forms a straight line. So again, we're talking about the supplementary theorem. So these 2 together equal 180. So I'm going to have to solve that. 5x plus 5 plus 10x minus 4 equals 180. And solve that. 15x plus 1 equals 180. Minus 1 minus 1. 15x equals 179. divide by 15, divide by 15, and x equals 11.93. I'll round there. Okay, so now we have to find the measure of angle 7, we've got to substitute this back into our first equation here. So 5 times 11.93 plus 5, and then substitute it into this one. 10 times 11.93 plus, minus 4. So this one was 64.65. And when I do this one, it's 115. Obviously, these are not to scale. 0.3. Because obviously this one's bigger than this one. So don't be surprised if you see that. It's so annoying. 55. Yep, that's right. And so I was wrong. It is a supplement theory. Supplement theorem. So let's take a look at this one. Oh, well, it says complementary. So this is going to be the complementary theorem. All right. So let's label. So 7 and 8 are complementary. That means these equal 90. Angle 8 equals 10. So this is the same as this. Measure of 7 is equal to 37. So how much is angle 8? So angle 8, since these two together equals 90, we'll say 90 minus the 37, which equals 53. Angle 10 we know is the same as angle 8, so this is 53. And obviously angle 9 would go with 7, which would be 37. Okay. Next, here's my favorite. These vertical angles. And you've got to draw a picture. There's just no way around these. I'm going to say that 5 million times, so just get used to it. So angle A and Z are vertical. So this is A, this is Z. They're vertical. They're across from each other. A is 3B minus 23. And Z is 152 minus 4B. Find the measure of angle A and measure of angle Z. If they are vertical, they are equal. Vertical angles are congruent. They're equal to each other. So let's do that. 3B minus 23 is equal to 152 minus 4B. I always send the smallest variable over to eliminate having negatives. 7B minus 23 equals 152. Add 23, add 23. 7B is equal to 175. Divide by 7. Where's my calculator? 175 divided by 7 is 25. How lovely is that? I like it when it works out. Okay, so now we have to substitute this back in. So measure of A is equal to 3 times 25 minus 23. The measure of angle Z is equal to 152 minus 4 times 25. And again, every time I'm substituting in, I always put parentheses. So 3 parentheses 25 parentheses minus 23, I get 52. So I really could put it down here. Angle A, I've got room, equals 52. And angle Z it should be the same thing, 52. All right. One more thing for this chapter. It's another proof. Okay, so in this figure, let's just understand the figure. In the figure, angle 1 and 4 are a linear pair. So 1 and 4 are 180 degrees. Angle 3 and angle 1 are 180 degrees. So I have a feeling we're going to be flip-flopping these around. Prove that angle 3 and 4 are congruent. Okay, 1 and 4 is 180. Prove that 3 is congruent to angle 4. All right, so we took what's given, put it here, and we write given. So to say linear pairs are supplementary, which ones are supplementary? Angle 1 plus angle 4 equals 180. That's saying that the linear pairs are supplementary. And then we could say angle 3 and angle 1 are, because that is, that definition, I'm going to turn this page over. Mine doesn't turn over very well. So we're talking about supplementary angles, so the congruent supplementary theorem. Where am I at? So you can see. What did I just say? The supplementary theorem? And then 4, supplementary angles to the same are congruent, supplementary theorem. So now we can just say what we were proving, which is angle 3 is congruent to angle 4. Okay, that's it for this chapter. We haven't really decided if we're just going to maybe even give you an amnesty day on Wednesday or whether we're going to give you the quiz on Wednesday. It just seems, I feel like you just need more practice with this. So we'll see how this goes, and by all means, give me some feedback. All right.